In this video we're going to look at solving quadratic equations by factoring. Some quadratics will factor. We've looked at quadratic equations and they can be written in the form ax squared plus bx plus c is equal to 0. In this particular video we're going to focus on examples when the value of a is 1. In the next video we will look when a is not 1. So an example of a quadratic equation where a is equal to 1 could be x squared plus 4x plus 4 is equal to 0. So sometimes we can go ahead and factor these and solve. Let's take a rectangle for now, and we will look now at an example of how we could factor and solve a quadratic equation. So if I take now some dimension, and I'll say that this is going to be x, so let's put here x, and then let's have x plus 1 just here. Let's say the area of this rectangle is going to be 42 units squared. We know that the length times by the width will give us the area. So what we can say is that x multiplied by x plus 1 is equal to 42. If you look at this now, we could probably do this without using any algebraic methods. A number multiplied by a number plus 1 is 42. I could use trial and error, and I'd see now that that would be 6 and 7. 6 times by 7 is 42. So we could do that. That's obviously not always going to be the case. So what we're going to do is look at factoring equations and then solving them. So let's take an example now. Let's say we've got x squared plus 5x plus 6 is equal to 0. The first thing I say to myself, is it in the form that I want? Ax squared plus bx plus c is equal to 0. So we have the x squared, then the x, and then no x. We're looking for two numbers that multiply to give the c. So this is the c term, so 2 that multiply. And we're looking for two numbers that add to give the b term. So this is the b term, and we need two numbers that add. So these two numbers are going to be the same. If you're unsure, just write down a list of the factors of 6. So we could have 1 times by 6, 2 times by 3, and that is all we have. So what we want to do is take two numbers that multiply to give positive 6 and add to give positive 5. These are the two that we're looking for. At this stage, all we do is set up a pair of brackets here and another there, and set this equal to 0. We have x and we have x. We're going to have plus 2 and plus 3. All I need to do is put those in. It doesn't matter if I put my plus 2 in here or my plus 3 in here. It really doesn't matter. It's the same thing. We know that 6 times by 7 is the same as 7 times by 6. So this is now factored. If you want to check to see if it works, expand it out. So x times by x, and I'll just do it here, would give me x squared. Then I would have now on the next one, I could do x multiplied by 3, so that's going to give me plus 3x. Then we'd have now plus 2x. And then finally we'd have 3 times by 2, which is going to give me the 6. And we can see now that that gives us exactly what we want. So two numbers that multiply to give the c and add to give the b. So from here, all I need to do is solve this. So if x plus 2 is equal to 0, we can say that x is equal to minus 2, as we saw in the last video. Or if x plus 3 is equal to 0, then x is equal to minus 3. So if you didn't catch the logic behind that in the last video, please go back and look at that. What we can see here is that we've got a positive number here and a positive number here. So if that's the case, if we have a positive number here and a positive number here, then these are both going to be positive. Let's look at another example now. Let's take x squared minus 7x plus 12 is equal to 0. So I'm first checking, is this in the correct order? Well, we've got the x squared, the x, the no x, and then that's equal to 0. So ax squared plus bx plus c is equal to 0. Two numbers that multiply to give 12 and add to give negative 7. So let's have a look at what that could be. 1 times by 12, 2 times by 6, 3 times by 4, and then we're back on ourselves. We can see now that the 3 and the 4 are going to work. We've got a negative here, and it's -7. So setting up the brackets, we're going to have x in the front of each bracket, x, and then we're going to have x. If I want to make now a positive number, I can have two negatives that multiply. Two negatives that multiply give a positive, and may add to give this negative. So we can write this as x minus 3 and x minus 4. So from there, now we can see that one or both of these must be equal to 0. So we can say that x minus 3 is equal to 0, so x would be equal to 3. Or x minus 4 would be equal to 0, which would give us x is equal to 4. So nice and straightforward, fairly logical, and we can use that method. So let's go back to our problem right here. This is what we've got. At this stage, it's not in the form that we would want. So what I'm going to do is try and put it in this form right here. This is the form ax squared plus bx plus c is equal to 0. So with this one, I'm going to multiply out the brackets. So we'd have x times x, which is x squared. Then we're going to have plus x, and that will be equal to 42. I want a 0 on the right hand side, and I want what we call c, or the constant, on the left hand side. So subtracting the 42 from both sides, x squared plus x minus 42 is equal to 0. So at this stage we can look to factor this. We need two numbers that multiply to give negative 42 and add to give 1. That's going to be now in my brackets taking an x, and then we'll have an x, setting this equal to 0. So I'm going to have plus 7, and then I'm going to have minus 6. 6 times by 7 is 42. This is a negative number, and this is a positive. If we have a negative number here, 1 will be positive and 1 will be negative. I chose plus 7, as if I'd chosen the negative 7 and plus 6, I would have had minus x. If you're unsure, just expand it out. So from here, x plus 7 is equal to 0, which would give us x is equal to minus 7, or x minus 6 is equal to 0, which would give us x is equal to 6. If we look at this right here, we can see now that this is the number that we want. Clearly, whilst this works algebraically, it's not a possible solution, as this length could never be equal to negative 7. We can't have a length. So sometimes when we solve quadratic equations, we get an answer we don't want, or, if you want a technical term, an extraneous solution. So whilst the algebra works, the actual reality of it doesn't. So just be a bit careful with that. So for example now, if I had x squared minus x minus 42, that was equal to 0. This time it would be x, and we'd have minus 7 and x plus 6, as that would give us now the negative here, because this is the larger number. Again, if you're unsure, just go ahead and expand it out. Let's look at another one. Let's go for x squared. So x squared, and then I'm going to have, I'll go for minus 8 is equal to 2x. I want to solve this quadratic equation, and I think I can do it by factoring. Most quadratic equations in reality don't factor. We have other techniques to solve them if they don't, but for now we're just working on factoring when this value of a, the coefficient, is just 1. So what I want this in the form ax squared plus bx plus c. So I'm going to subtract 2x from both sides. So x squared minus 2x minus 8 is equal to 0. X squared, x, no x. I need two numbers that multiply to give negative 8 and add to give negative 2. 1 times by 8, 2 times by 4, and then we're back on ourselves. So the brackets get opened up, and we will set that to 0. If I look at this, I know I'm going to have my x in the front of each bracket. I've got minus 2, so this is going to be plus 2 and minus 4. So I can put them in any order I want, minus 2 and plus 4. I can't have minus 2 and then plus 4. as if we wrote this, that would be x squared plus 2x. Again, if you're unsure, check it, just expand it out. So x minus 4 is equal to 0, which would give us x is equal to 4, or x plus 2 is equal to 0, which would give us x is equal to negative 2. So all we're doing is simply taking this value and we're going ahead and writing now the opposite. Let's do another one. Let's say we have x squared is equal to, and we'll go for x plus 6. So x squared minus x minus 6 is equal to 0. A killer error here is students try and square root at this stage, but all they're going to do is get x is equal to something else with an x in, which is not doing what we want. Okay, so let's deal with this one. We need two numbers that multiply to give the c term and add to give the b term. So what we've got here is negative 6 and negative 1. So we can have 1 times by 6, 2 times by 3, and we're back on ourselves. So opening up the brackets, we're going to have now the 2 and the 3. We're going to have x, we're going to have x. We'll take the negative 3 and then the positive 2, as that will give us the negative. So we can say that x would be equal to 3 or x would be equal to minus 2. And that gives us the solutions. Let's do another one. Let's say we've got the following. And I'll make this one slightly more challenging. Let's say we've got minus x squared. And then we've got, we'll go for plus 5x. And then that will be equal to now negative 24. Okay, so this one now we've got a minus term. All I would do is simply add the x squared to both sides and subtract the 5x. So the left-hand side of the equation becomes 0, adding x squared, subtracting the 5x, and then rewriting the negative 24, that's what we'd have. It's now in the form ax squared plus bx plus c is equal to 0. So we want two numbers that multiply to give negative 24 and add to give negative 5. So if I think about this, 1 times by 24, 2 times by 12, then we'd have 3 times by 8, 4 times by 6, and then we're going to be back on ourselves. So I'd have now my two sets of brackets, and then we'd have x. I'm going to have now these two right here. They have a difference of 5. So we can say now that it's going to be negative, so it's the negative 8 and the positive 3. We can see with this negative we're going to have one positive and one negative. If it was positive, we'd either have two negatives or two positives. So from here we can say that x would be equal to 8 or x would be equal to negative 3. Do check that these answers work. So if you wanted to put it back in, that would give us now on here negative x squared, so we'd end up with taking 8, this is taking 8, plus now 5 lots of 8, which is going to give me 40, which does equal now negative 24. So we can see now that it does work for, certainly for 8, and we can put the values in and solve as well to check that this works for negative 3. So that's when we have a negative. We will look in another video at how dealing with more tricky ones. Okay, let's take another one. Let's say we've got 2x squared, and then we'll have plus, and we'll go for plus 6x, and then we'll have this one equal to 20. The whole video focuses on when x squared, the term in x squared is 1. So what I'm going to do with this is divide both sides of the equation by 2. If I do that, I'm going to end up now with x squared plus 3x is equal to 10. I want this in the form ax squared plus bx plus c is equal to 0, x squared plus 3x, then we're going to subtract 10 from both sides, and that will be equal to 0. I now need the two numbers that multiply to give the negative 10 and add to give positive 3. One's going to be positive, one's going to be negative, so I can write this now as x plus 5, and then we're going to have x minus 2 is equal to 0. After a while, you'll just spot these and it will become second nature. X would be equal to negative 5, we've got x equal to 2. So nice and straightforward. All we've done is rearrange and then found those two numbers. We'll look at another one. We'll look at x minus, let's go for x squared minus 6x plus 9 is equal to 0. If we look at this now with 9, 1 times by 9, 3 times by 3, we can see that this is going to be x minus 3 multiplied by x minus 3, and that will give us 0. Often we write this as a perfect square, which is x minus 3 all squared. If we had p times by p, this would give us p squared. So if we have x minus 3 multiplied by x minus 3, that's x minus 3 all squared. So with this one, we have x is equal to 3 or x is equal to 3, which gives us one repeated solution or root to the equation. They're often called roots or solutions to the equations, and that would give us 1. So quite a nice one there, just to rewrite it like so. Okay, I'm going to do something now where this is not absolutely obvious, and we will cover it in another video. Before, we looked at the example of x squared is equal to 36. So in the first video, we looked at square rooting both sides of the equation. So x was equal to plus or minus the square root of 36. That gave us that x was equal to plus or minus 6. What we could have done here is use what we call the difference of two squares. So I can rewrite this as x squared minus 36 is equal to 0. This is a square number, this is a square number, and this is a difference. Difference means subtract. When I have this, I can write this as 2 brackets, and we could write this now as x plus 6, x minus 6. If we think about this now, and I'm going to expand this, I'm going to expand x times by x, then x multiplied by the negative 6, then I'm going to do the 6 by the x, and the 6 by the negative 6. We're going to end up now with x squared, then we'll have subtract 6x, so take 6x, then we're going to have plus the 6x, and then we're going to have now negative 36. These two terms are going to cancel, and that leaves us x squared minus 36, and in this case was equal to 0 as I set it as an equation. Sometimes you'll just be asked to factor the difference of two squares as an expression. So as you can see now, we can rewrite x squared minus 36 as the difference of two squares. In a later video, we will see how that can be quite beneficial. So for example, 4x squared minus 9. This is a square number. 4 is a square number. X squared is a square number. That's a difference. That's a square number. So we could factor this as 2x plus 3 multiplied by 2x minus 3. So nice and logical. After a while, you'll get used to it. The take-home message from this particular video is that if we can factor a quadratic equation, that's the best way of dealing with it. To end with, we will just do one really quite challenging one that you'll probably come across later in your studies. We'll have x plus 1 is equal to 12 over x. I'm going to multiply both sides of this equation by x. If I do that, I'm going to have x times by x, which is x squared, plus 1 times by x, which is just x, and then that's going to give me 12. If I multiply 12 over x by x, I just get 12. I'm going to subtract 12 from both sides. X squared plus x minus 12 is equal to 0. Now I can look to factor this. Two numbers that add now to give negative 12, so multiply to give negative 12 and add to give 1. This is going to give me x plus 4, and then we'll have x minus 3 is equal to 0. So x would be equal to negative 4, or x would be equal to 3. So that's what we often call an equation that has a hidden quadratic that it will reduce to. So that's what we have. Nice and logical. Put it in the form ax squared plus bx plus c is equal to 0. Two numbers that multiply to give the c term and add to give the b term in a set of brackets, and then our solutions are going to be the same numbers with the opposite sign.